All right, we're going to go ahead and look at some statistics information, and we're going to do a couple different sections. First, let's look at describing data. We have measures of central tendency, which would be mean and median. So the mean is typically described as the average. We have a symbol for that, and it's the Greek letter mu. So it looks like a cursive M here. Now the formula for mean, okay, mu equals, typically you would sum, okay, that sigma, sum the data points. Now the I subscript here is the counter, so I starts at the first data point and stops at the last data point. And then we divide by the number of data points. So sum the data points and divide by n. Now the median is the middle number. We have two measures of spread. One of them is the range, and that is found by taking the max number and subtracting the min number. A new one that you might not have heard of before is standard deviation. This is going to be one of the important ones for our notes, as well as mean. Okay, so the standard deviation is the average of the distance from the mean, average distance from the mean for all data points. All right, so we're going to look at the formula for that. Now the symbol is an O with a little loop here, and that's lowercase s in Greek. Okay, in order to find the average distance from all of the data points, first we have to find the distance from the mean. Okay, in order to find the distance from the mean, we take the data point and we subtract the mean. I want this to represent distance, and I want it to be a positive number. And so I'm going to go ahead and square it. Squaring the number will make it a positive. Now I need to add up all of these distances. So I'm going to sum the distances. Now I need it to be an average. So similarly to the first formula, we're going to divide by n. Now this was a square, and what I really want was the actual distance number. So instead of keeping the square here, we're going to put the square root symbol around all of it. This is where the least squared regression comes in, where you have a minimum distance from the average. Let's go ahead and calculate the standard deviation with this small set of numbers. First thing I want you to do is find the mean. 8, so this adds up to 18, so the mean is 6. And let's start by finding the distance from the mean. -3. Okay, now let's square it. Okay, so let's check my formula. Okay, so I've squared it. Now I need to add them up. Okay, so this was the sum. Okay, now I need to divide by n. Okay, so that's 26 over 3. So that is 8 0.6 repeating, and now I need to square root. .944. Okay, there's my calculator work. This number right here is the standard deviation. That means on average, the data points are 2.9 units from the mean. Some of them are a little bit further, some of them are a little bit less. Let's go ahead and highlight here. These are important formulas that you'll have to recognize. You won't have to memorize them, but you will have to be able to use them. All right, let's talk about what a small standard deviation would mean. This would mean data points are close to the mean. A big standard deviation would mean data points are far from the mean.
2 new passes are in my mailbox. Sorry.
Let's draw a number line. And let's say that the mean is 4. That means that some data points will have no distance from the center, but if we have a small standard deviation, then lots of data points will be close to the center, right? If you have a large standard deviation, let's assume the middle is 4, right? Let's go with mean. Let's go with mean. And we have a big standard deviation. That means that the data points would be very spread out, farther away from the mean than these points here. The collection of points around the mean gives it a small standard deviation because the distance is small. Here, on average, the distance from the center is much bigger. All right, let's move ahead a little bit, and we're going to look at statistics, not describing the data, but we're going to look at something called the normal distribution. Okay, there's 3 properties of the normal distribution. The first one is the mean equals the median. Means the average is actually the middle number. And this will create a symmetric bell-shaped curve. Okay. Second property is the area under the curve equals 1. And the third one is the empirical rule applies. So let's go ahead and look at how the empirical rule applies to the normal distribution. This is how we're going to measure probability. The empirical rule states that 68% of the data points will fall within 1 standard deviation. This has to do with their distance from the mean. The second part is 95% of the data points will fall within 2 standard deviations of the mean. That's above and below. The third statement is 99.7% will fall within 3 standard deviations. Okay, so let's go ahead and look at what a normal distribution is. And we're going to go ahead and label standard deviation and the mean. So if we look at the center, okay, the middle point, right here, mean. Each of these lines represents one standard deviation. So this is 1, 2 standard deviations above the mean, 3 standard deviations. And I'm going to label the left. 1 standard deviation below, 2 standard deviations below, and 3 standard deviations below. So we're going to see if we can label each of these 8 vertical sections with the appropriate percent. Okay, so 68% of the data points will fall within 1 standard deviation. So that's going to be this section right here. Because this curve is symmetric, okay, we can see the left half and the right half are equal. What number goes in each of those sections? So 68 is the whole, okay, 68 goes here. That means each is going to be 34%. Okay, let's look at the 4 sections within 2 standard deviations. So that would be from here to here. And that's going to be 95% of the data. Okay, can you figure out what goes in each of these remaining sections? Okay, that would be right here. Okay, so I'm looking. If I have 95 and I already took out 68 for the middle 2, I've got 27 left, split evenly, so 13.5. 13.5. Okay, the next one says 99.7. So between here, all the way over, 99.7% of the data will fall within these 6 sections. See if you can figure out what goes in this small section right here. Okay, so we have 99.7 and we've already labeled 95%, so that leaves me 4.7 split evenly. That's 2.35. 2.35. Now that covers within 3 standard deviations, but we have this section left outside. Okay, so what goes in the last 2 sections? Well, we have 100% of the data points. We've already labeled 99.7, and so we have 0.3 left, divided evenly. Now there is no endpoint here. This is just outside of 3 standard deviations. Notice that together, right, all the way on the left, all the way to the right, would give you 100% of the data. You are going to need to memorize this rule. It's easiest, because of the symmetry, to remember those 4 numbers and then copy them over to the other side. All right, we have one more piece of vocab to look at before we get into some examples. Okay, we're going to look at measures of location. The first one is the z-score, which is how many standard deviations away from the mean, word and symbol, the data point is. Okay, so let's see if we can write our formula. So z equals how far from the mean? So distance from the mean. Okay, distance from the mean, subtraction, in terms of standard deviations. If a data point is 34 and the mean is 42, what is the z-score? Can you figure out how many standard deviations away from the mean this data point is? No, you're missing information. Let's say that the standard deviation is 1.5. How many standard deviations away from the mean is this data point? Well, the first thing I notice is that the data point is to the left of the mean. Okay, so z-score equals mean sorry guys, I just realized. All right, we got to switch this. Data minus mean. That would be the distance from the mean. So let's fix it. 34 minus 42, because I know that this distance from the mean is -8. Now everything is matching. Okay, so let's go ahead and divide that. This you do get to use a calculator for. It's a calculator unit. -5.3 repeating. The data point 34 is -5.3 standard deviations from the mean, which implies it is below the mean with the negative z-score. The other measure of location is a percentile. The percentile is a percent, so that is between 0 and, I'm going to say, 99. Okay, and this represents, okay, the percent of data at or below a certain data point. All right, so let's do a little bit of labeling to see what this looks like. Here's our normal distribution, and we're going to label the normal distribution with percentiles at each whole number standard deviation. And this is rounding down. Okay, so let's go ahead and put mean, 1 standard deviation, 2 standard deviation, 3 standard deviation. Those are above the mean. So now let's label below the mean. -1, -2, -3. Okay, now we're going to start here at -3 standard deviations. And what percent of data falls below this point? Okay, so think of those numbers we just memorized. I'm going to look back. It's 0.15. Okay, round down. That would be the 0 percentile. Okay, so now let's look at the next section. So I want all of the data that is below this data point. Okay, so I'm going to look at, so that's 0.15 plus. What percent of data is in this section? 2.35. So that's 2.5. But this is a round down to the nearest whole number. Okay, so this is the second percentile. Okay, let's go up to the next marker. Okay, what is the percentile for a data point at -1 standard deviation? So I need to add up all of those percents. So that's 2.5 plus, okay, I gotta go look, 13.5. So that gives me 16. So this is the 16th percentile. Okay, next, all the way to the mean, the middle data point. Okay, so the percentile is the percent of data points that are at or below a certain value. So at the mean, so I've got 16, and we get 34 more. That's the 50th percentile. So the mean, or the middle number, is the 50th percentile. So let's keep going. Okay, we've got one standard deviation above. So I've already got 50 for half of it, and the next section is 34. So that would be the 84th percentile. All right, 2 standard deviations. We've got this section. I have to add more data points. So I check, my number is 84 plus 13.5 and 97.5. That is round down. So that is the 97th percentile. Okay, last section. 3 standard deviations above. Notice it's not quite all of the data values. There's still this one section over here. Okay. 97.5 plus 2.35. So that gives me 99.85. Round down. This is the 99th percentile. The reason that this is a number 0 to 99 is that unless you are the absolute highest data point, you're never going to be in the 100th data point or 100th percentile. There's always a possibility that someone is slightly above. Okay. There's your vocab. You have the formulas that are boxed and highlighted, and then you have the empirical rule that you have to know. Let's go ahead and try some of these examples. Okay, using the empirical rule. Assume that the dog's ages are normally distributed. Okay, vocab number 1. With a mean of 4 and a standard deviation of 2. So let's label our mean, standard deviation, and the empirical rule percentages. 4. Now with the standard deviation of 2, I'm just going to go ahead and add 2. Now I understand that dogs' ages can't possibly be -2, but we're just going to have to do our best to interpret the information. What percent of dogs ages, percent, would we expect to be between 4 and 6 years old? And so it's this section right here. And so I check my chart of numbers I've memorized, and I get 34%. This represents probability, which is going to be that number between 0 and 1. What percent of dogs are younger than 2? Okay, so I'm looking at this section. So that would be okay, let's see if I can't label. I'm going to label both sides here. 13.5, 2.35, 0.15. So that would be these three numbers. 0.15 plus 2.35 plus 13.5. And so that gives me 16%, or probability 0.16. Notice that this could also be the whole of 1 minus 0.16, or 100% minus 16%. What percent of dogs are older than 6? Here's 6, and older is shaded here. Now I notice that question 3 and 4 look symmetric. They're just on opposite ends of this graph. Okay, so I look at 6. So we get 13.5, 2.35, and so that is 16%, or 0.16 for the probability. Let's look at practice number 2. Same curve, so I'm going to go ahead and label it. Label with percentile. So I'm going to see if I can remember these. Okay, so I know that this middle one is 50. And I know that I get 84. Okay, 16. And then I have to start thinking. I actually have to add up. 0.15. So I know that this is 0. I know that this is the second. Okay, so this is plus 84 plus 13.5, so that's the 97, and this is the 99th. Okay, how old is a dog who is in the 16th percentile? And so I'm looking right here. 16th percentile, drop it down. The age is 2. Notice that this was the age of the dog. The dog is 2. How old is the dog who's in the 99th percentile? So I scan for my 99th percentile. The dog is 10. What is the dog's percentile who is 8 years old? Okay, this time we're going to start with the data point and end at the percentile.
Apologize for the bell ringing. We do have some information.
Okay, what is the dog's percentile who is 8? So we start at the age of 8 and we go up to the percentile. So 97th percentile. What is the dog's percentile who is 4? So we start at 4 and go up to the percentile. 50th percentile. Same data set, so 4, 6, 8, 10, 2, 0, negative 2. If there are actually 180 dogs, how many dogs are more than 2? Okay, so this is the portion of the graph. Now, if I want to know how many dogs, this is a ratio that you set up. So I have how many dogs out of 180 equals what percent? Okay, what percent? Oh, okay, so I've got to add this up. We've got 34 and the other side is 50, so that's 84. So go ahead and find x. X equals 180 times, okay, let's type that in. Okay, so that would be 151.2. So in this particular case, I'm only going to report the whole number of dogs. So 151.2. Oh. 151 dogs. If there are actually 50 dogs, how many are between 4 and 8? Okay, so what percent of my data points are between 4 and 8? So that's 34 and 13.5. So that's 47.5%. So how many dogs out of 50 is 47.5%? Okay. $23.75. I'm still going to round down to the nearest whole number and report only the whole number of dogs. Okay, next type. Assume the dogs' ages are normally distributed. Okay, mean 4, standard deviation 2. How many standard deviations away is a dog who is 2.5 years old? I'm going to set this up in a number line format for a visual. So my mean is 4 and my standard deviation is 2. Okay. Oh, 2.5, so that dog who is 2.5 years old. So the data point is about here. And so this is my mean. It looks like he's less than 1 standard deviation away. So let's see if we can't figure this out. Z-score equals data point minus mean over standard deviation. Okay. 2.5 minus 4. Okay, so we get 1.5 negative because the data point was below the mean, and divide. And so we end up with a z-score of negative 0.75. Corresponds to the picture that I drew. How many standard deviations away is a dog who is 0.5 years old? Okay, so I've got the 4, 2, 0. So 0.5 is here, means it's going to be a negative because it's below the mean. Z equals 0.5 minus 4 over 2. Negative 3.5 over 2. Negative 1.75 for the z-score. If the age of the dog is 2.3 standard deviations above the mean, how old is the dog? 2.3. So if I look at my number line, the average, 1 standard deviation, 2. So the dog is going to be more than 8. Okay, let's see if we can find it. Exactly, 2.3 standard deviations above the mean. The data point is unknown. And solve for x. As we expected, our data point is slightly more than 8.